In this video we're going to be talking about angles of polygons. Angles of polygons. Poly means many. Prefix poly means many. And gon refers to sides. So this is referring to any multi or many-sided shape. So the first one we have, first type of polygon we have is a triangle. Tri meaning three angles. It also has three sides, so it's a three-sided shape. It's the first type of polygon. And triangles, their angles are their, more specifically, the sum of their interior angles, all of the inside angles, add up to 180 degrees. Hopefully you know that at this point. Well, we're going to use this. We're going to make triangles into other shapes, or we're going to say that other shapes are created by many triangles. Doesn't matter how many. They can all be made out of triangles. Triangles are kind of the building blocks of all other shapes. Alright, the next type of polygon we have is a quadrilateral. Quad meaning four. Lateral referring to sides. So this is a four-sided shape. And if we actually cut this quadrilateral in half by drawing what's called a diagonal, this is called a diagonal, and it looks diagonal, right? But a diagonal more specifically is when you connect a vertex to the opposite vertex. That is a diagonal. So what did we just do to this quadrilateral? Well, we just broke it up into two different triangles, right? So how many total degrees would the inside angles make, or the sum of the interior angles? That's really where we're getting to today. Well, we know a triangle has 180 degrees, and another triangle has the same amount, 180 degrees. So what did we just do? We doubled 180, and we created 360 degrees. That's the sum of the interior angles. Sum of interior angles. That's our shorthand right here. We can continue to do this. We'll go to a five-sided shape next, and we'll talk about the sum of the interior angles, and it's always going to be 180 degrees more. However many more triangles we can draw, we're always going to add 180 degrees to it. So eventually we're going to come up with this formula where we don't have to draw triangles anymore. We can just plug the numbers into a formula, and let's just write it down right now. It's going to be the number of sides minus 2, and we're going to multiply that by 180, because really the number of sides minus 2 is going to tell us how many triangles we can draw, and that's going to give us the sum of the interior angles. So we can always figure out the sum, or how many degrees all of the angles inside a shape add up to. That's really what we're talking about. If we add up all of the angles inside a shape, it will give us pretty much what this formula equals. N minus 2, number of sides. Let's write that down. Number of sides. So let's just check what we got so far. We got a triangle. That's three sides. So 3 minus 2 is 1. And 1 times 180 is 180 degrees. That's why there's 180 degrees in a triangle. Makes sense. Let's check out our quadrilateral. It's four sides. So we're going to substitute 4 into n, which represents the number of sides. So 4 minus 2 gives us 2. And then 2 times 180 gives us 360 degrees. Alright, let's continue. Let's draw triangles, but really let's focus on this formula. And let's just check it with drawing pictures here. So let's go to a five-sided shape now. Now we draw pretty much a house, or what's known as a pentagon. Penta meaning 5. So this is five-sided. 5-sided shape. And the shapes don't have to be up the same way. This could be sideways or upside down. Doesn't always have to be facing up. So let's use our formula first. N minus 2 times 180. That's going to give us the sum of the interior angles. So it's 5 sides minus 2 times 180. So 5 minus 2 is 3. 3 times 180 will give us 540 degrees. You should be able to do this in your head. If you break this down, use your distributive property. 3 times 180 is really 3 times 100 plus 3 times 80. 3 times 100 is 300. And 3 times 80 is really 3 times 8 with just a 0 on the end. So 3 times 8 is 24. And if we put that 0 on the end, then 3 times 80 is 240. And if we add 300 plus 240, we get 540 degrees. So let's check it using our triangle drawing method here. If I draw a diagonal from that vertex to that vertex, I've created one triangle. And if I draw a triangle from this vertex to this vertex, I got another triangle. So really we have 3 triangles, right? We had 180 degrees there, 180 degrees there, and 180 degrees there. So it's 3 times 180, right? Well, that's what we ended up doing, right? At this step right there. So it was the number of sides minus 2, that gave us 3. That turned out to be the number of triangles, and triangles are 180 degrees. So if we multiply 180 by 3, we get 540 degrees. Alright, let's do another one. And oh, back up a step. It really doesn't matter where we draw our triangles. If I were to draw, yeah, let's draw a sideways pentagon, just to prove a point. It doesn't matter how it faces. But again, you don't have to draw the diagonals a certain way. I could have drawn the diagonals this way and broken it up. And it really doesn't matter. Any way you draw those diagonals, there's really only 3 triangles that you can create. So if you don't want to get stuck trying to figure out the correct number of triangles, use this formula. That's all you need. Number of sides minus 2 times 180. Let's do another shape. Let's do what's called a hexagon. Hexa meaning 6. So this is a 6-sided shape. 6-sided means kind of have our house, except now we got 2 tips. 1, 2, 3, 4, 5, 6 sides. So number of sides minus 2 times 180. That's 6 minus 2 times 180. So 6 minus 2 is 4. 4 times 180. Well, that's really 4 times 100. That's 400. And 4 times 80, or 4 times 8 with a 0 on the end. 4 times 8 is 32. So just put a 0 on the end. So 4 times 80 is 320. Add it together. 720 degrees. If we were to add up all these angle measurements inside this shape, we would get 720 degrees. Again, draw your triangles. Doesn't matter how you draw them. Let's draw from that vertex to that vertex. There's a diagonal. There's a diagonal. There's a diagonal. So we got 1, 2, 3, 4 triangles. Well, that's what we ended up with after we did number of sides minus 2. And we multiplied that by 180. Also, if you are a snowboarder or skateboarder or anybody that does flips, hopefully these angle measurements start to make sense. These are really revolutions around a circle, and they're very similar to the interior measurements of a shape. It all kind of fits together. So 720 degrees is really when you spin around once, that's 360, and then you spin around all the way, that's 720 degrees. And it's the same measurement as the inside angles of a hexagon. It just happens to match up. Let's do another shape. And again, you could do this pretty much all day long. The hardest part about this is really if you're not given the shape, if you're just given the name. So let's step up. Let's skip the heptagon, which would have been 7, and do an octagon. Octopus, 8 arms, so an octagon has to have 8 sides. Octa means 8. Looks like a stop sign. 1, 2, 3, 4, 5. Oops, didn't do enough here. There we go. There's our missing side. There we go. 1, 2, 3, 4, 5, 6, 7, 8. It's a stop sign. Alright, if we actually draw our diagonals, there's one. There's another one right there. Here's another one right there. Another one right there, and there, and there. So how many triangles? 1, 2, 3, 4, 5, 6. 6. There's just 6. If I had drawn a better shape, it would have made more sense, huh? So number of sides minus 2 times 180. So we end up with 6 triangles. And if we multiply 180 by 6, we should get the interior angles, a stop sign, or more specifically an octagon. 6 times 100 is 600. 6 times 8 is 48, and we're going to put a 0 on there and add it together. Get 1040 degrees inside an octagon. So really the hardest part is if you're just told how many degrees are inside an octagon. Well, you'd have to know that it was 8 sides. And if you knew that much, you could just do your formula. Or if you knew how to draw an octagon, you could draw the number of triangles and 180 degrees in each triangle, multiply 180 by the number of triangles you created. Either way you do it, this is how you find the sum, how much we add up all the interior angles of any polygon, any sided shape. So again, most important thing is this formula right here. Number of sides minus 2 times 180. That will give you the sum of the interior angles every time, no matter how many number of sides. Number of sides. Alright, so go ahead, try it out.